And inside the Python interpreter, it has what is called a heap. And inside the heap, it stores objects. And some of these objects have, some of these objects are still needed, and some of them might not be referenced from any variables. So what Python does is it has a garbage collector, and every now and then it will search through all of the variables in the scope, and it will trace all of the objects that are still referenced. So, for example, suppose you've got this sort of reference structure here. When it does garbage collection, it will go through and mark all of the ones that are still referenced, and this is a reference from a local variable. And then it will go through and it will delete the objects that aren't referenced from the local variable. Now, it can't do this with pointers in C, because in C, C is, at execution time, C is untyped. So you could potentially have a value stored as an integer, which is actually a pointer, or you can have values within a struct of pointers, and there's no way for Python to know which things you've got referenced from C. So if you have a C object here, and one of the fields of that references a Python object, what you have to do is you have to tell Python that you have a reference to that object. Okay, and you do that by calling pyincref. And similarly, you can call pyDecref to say that you've got one less reference to that object. And Python, when it does its garbage collection, it will make sure that any objects which are referenced from C will not get deleted. If you don't do that, you will end up with objects being deleted from memory while you've still got references to them. And then after that, when you try to use that reference, your program will probably crash. So you always have to make sure that you maintain reference counts appropriately. Now, when Python calls a C function from Python code, it expects to get what is called a new reference to the return value. So if you've got an object which already exists in memory, what you have to do is you have to increment the reference count and then return that back to the caller. And then when the caller's finished with it, like it could keep the object and keep the reference count incremented, or if it no longer needs the object, then that will call pyDecref. So it's important to understand how reference counts work and be careful when you're programming those. And by the way, there's some really good documentation about this on the Python website, and I'll give you a pointer to that at the end as well. Okay, so once we've defined our wrapper function, we define an array of structs, and each member of that corresponds to one of these wrapper functions. So we have the name of the function, and then we have a pointer to the actual C function and check the next. And then there's some flags here, just use arrows for that. And then in this initialization code, what I do is create a Python module, and I say that the methods that are in that module are specified by the game methods array. So a module in Python is like a package in Java. It's a way of grouping classes and functions together. So the game module basically just has a name and then a couple of other fields, and then it has the methods. So an initialization just gets pulled from the main method, and then that says create a new Python module with these parameters, and then that will say, okay, register those methods that are visible in the object. Now, normally in Python, if you want to use a module, you have to do import and then the name of the object, the name of the module at the start of the file. But to simplify things, because we want to keep the scripting interface as clean as possible, at the initialization, after it's set up the module, I run a Python command which says from game import start. So pyrun simple string means execute the Python code that is contained within the string parameter. and then I use that again later on when I run the script. So I've got this line of code reads the contents of game.py, which contains the script for the game. And then later on, after I've done some other setup, I call run simple string again with that script there. So that means that it will just execute the code that I read in that file. Is there any questions about that so far? Okay. So I want to talk about the other way that you can interface with Python, which is you can have objects which are accessible to the script. So in the script, I've referenced enemy objects and I've referenced player objects. So, for example, when in the attack player function I say get the angle between the enemy object, the current enemy object and the player object. Now, both of these objects are Python objects, but they're used by the C program as well. And I can actually call methods on these. So if I wanted to, I could put something at the start of the script which puts the player in a different position. So by default, I'm just going to exit DOSBox because that's slow. When you start up the game, normally it puts it at, I'm not sure what position, 320 by 340. But if I wanted to, I could say I want to put the player at position 50 and just put it up in the top left corner. So I can do that by editing my script and say player.x equals 50 and player.y equals 50. And then that would position the player at that location. So I have access to this variable in scope, which is a player object, and then I can set fields on it just like I can any other types of fields in Python. Now, so there's a couple of ways that, or there's two key things that you need to do there. I'm going to show you about initializing the player object in a moment, but you probably would have noticed back in this initialization code, right before I had to run the script, I had this pydict set item string player, and then pointing to this player object. So set item string, the main dict is the dictionary which maps from variable names to variables in the global scope. So when I call set item string with this main dict variable, that says declare a new variable called player, which refers to this player object. And that's what enables me to reference player.x and player.y directly from the script. But there's actually a lot more to it than that. So when I want to create a new object that I can use in my Python code, what I have to do is I have to set up a couple of structures. So I need to declare a PyObject type structure, and this declares information about the type of the object and how much memory it needs. If I go into my header file, this is where I've declared the structure IoT. The only difference between this and a normal object is I've got this thing up the top called PyObject head. Now that's actually a macro which is defined in the Python header fields, and that declares some extra fields in that object that are used by Python. So if I want to use this as something which I can reference from Python and from C, then I allocate it just as a normal string object, and with those fields at the top I can use it as a Python object. By the way, I've got the code for this on USB. I deliberately avoided having networking capabilities in this talk. Right, so we've got a struct definition with these extra header fields added in there.